Rishabh, please summarize. What did you study in the last class? Rishabh, what did you study in the last class? Yes. What did you study in the last class?
The thermodynamics.
Wow. और बोलना physics पढ़ा. हाँ? Physics पढ़ा बोल.
थोड़ा रिवाइज करना पड़ेगा.
उसके बाद बोल science पढ़ा.
सर मैथ्स नहीं सर, हम लोग का मैथ्स क्लास होना तो वो ही रिवाइज किया था.
टाइम पास करता है, झूठ बोलता है तो ठीक है, झूठ किसी और से बोल. We studied about different type of system. Yes or no? Dhruv, you agree with me? Swaroop, different type of system we study. We studied about what is open system, what is closed system, and what is isolated system. So what is open system? Dhruv, what is open system? What is open system?
Sir, I don't remember.
Why? Why you don't remember? Are you an old man? Swaroop, what is open system? Swaroop, what is open system? See your notes, no. Why are you asking me? I don't know. Look at your notes and tell. What are open system? Swaroop. स्वरूप, पूछ रहा हूं तुमको कुछ.
हाँ सर.
एक हाँ बोलने के लिए तुमको 5 मिनट लग रहा है. आई एम शाउटिंग. व्हाट इज ओपन सिस्टम? बंद कर दो क्लास. आई डोंट वांट टू टेक क्लास.
सर मैं बोलूं?
पूछ रहा हूं ना तुमको.
सर
नहीं पूछ रहा था तेरे को. मैं सबको पूछा पहले. बता.
Sir, open system is a system that freely allows matter and heat to the surrounding.
Example?
So example, sir, water vessel which is uncovered, hot water vessel.
Very good. What is closed system?
So मैं ही बोलूं?
हाँ तू ही बोल.
So closed system is a system that only allows the heat. Sorry, that.
Yes, you're correct.
That get exchanged.
What gets exchanged? Heat gets exchanged, not matter.
Heat gets exchanged.
What is isolated system?
Sir, which
do
neither
not allow
allows heat nor matter.
Yes. Example, thermoflask.
To the surrounding, thermoflask.
Tea in a thermoflask. Hot tea or a cold tea in a thermoflask. Now I will say, yes. So we studied about 3 systems. One is open system, and again I am repeating. Open system, closed system, and isolated system. When you talk about a system, I am having a vessel, hot water vessel, boiled water and kept outside. You will see what will happen. The water also evaporates as water vapor, and also the heat also evaporates. That means if you keep your hand here, you will feel heat. Why? Because heat also escapes. Understood? So this is open system. Sir. Closed system, you are covering a lid and keeping it, but still you can feel heat hot. Why? Because the heat is evaporating, but the matter is not going. Why? The matter is getting stuck here. The water vapors are still under here, so matter is not going. Though nothing is 100%, you cannot say it is a 100% closed system. There is nothing in the world which is ideal. Yes or no? Everything, there is a loss. Here also matter gets exchanged. Okay. Third, we are talking about. Yeah.
सर कुकर भी, कुकर को तो अपन टाइटली ये करते हैं ना.
कुकर is isolated system because cooker is allowing heat to go, but matter does not go. So it will come. It will be neither open. It will not be isolated. It will be a closed system. Okay, because heat, matter is not going. Though matter goes, I'm saying nothing is 100%. Cooker also through steam, what goes? The water goes, no? Water content.
Yes, sir.
But naturally, it is a closed system, but it is not a complete closed system. There is nothing 100%. There is nothing 100%. Even the thermoflask, when you talk about, it's a closed, it's isolated system. That means what? The heat will never come out. Is it so? No. The thermoflask has hot water. It will last for 2 days or 3 days. But after 3 days, 4 days, it will become cold. That means heat is going, but very slowly. Is it clear? Is it
Yes,
clear?
sir.
This is all we studied.
Sir,
in the
last वाला
class.
आपस बताओ ना.
Thermoflask. What is thermoflask? What do you mean? What you normally, thermoflask is a system which is a completely isolated. Means if you have seen thermoflask, have you seen thermoflask? How it will be? The thermoflask will be very big, will be thick, but
Yes, sir.
you will see some kind of glass inside. Why? It's a special containers which is completely isolated, which will not allow heat to come out. That's why thermoflask is normally used. Corona time people used. Why? Because Corona time people were using hot water. Not Corona time. Normally, when people are diseased or people are not well, they will normally use hot water because hot water is good for health. So now they can't continuously go and fill the water. So what they do, they directly fill the water and keep it, and they can use it for a day. So in a closed, in an isolated system, the heat and matter will not come out. Matter will never come out. Matter will remain same. Even heat also is never come out. So but that is not the case. I'm saying nothing is 100% efficient. Maybe 98% or 95% or maybe 70% based on the quality. I have a thermoflask which keeps 2 days. Understood? 2 days. So thermoflask is the best example of a isolated system. Is it clear?
Yes, sir.
Yes, sir.
We also studied about system, surrounding, boundary. What is system? System is defined as a specific part of the universe. I have a complete universe. Okay, let's say this is a complete universe. The small part which I'm taking is called system, which I am focusing on. I want to do experiment. That is called system. And what is the boundary? The boundary is something which separates the system from the universe. Is it clear? So write down
Yes, sir.
universe equal to system plus surrounding. This is a universe, everything. This is a surrounding. Inside surrounding, you have system. Outside system is surrounding, and everything else is called, when you take house, you say no. Near my house, there is nothing, no shops. What do you mean by say near my house? You are talking about maybe some distance. Yes or no? Some locality. Maybe a 1 kilometer radius or half kilometer radius. That is called surrounding. But beyond that, that is universe. Did you understand what is universe, system, and surrounding?
Yes, sir.
Yes, sir.
Yes, sir.
So boundary. When you talk about boundary, what do you will say? The boundary is something which separates system from surrounding. Boundary. This is a boundary. Boundaries separate the system from the surrounding. So this boundary are of 3 types. One is conducting. One is conducting or non-conducting. Means either the boundary will conduct heat and electricity or it will not conduct, be insulator. That is first. Second, boundary can be rigid. Can be rigid or non-rigid. They are called types of boundary. Write down. Types of boundary. Rigid or non-rigid. And third is boundary can be real or imaginary. Clear?
Yes, sir.
So example,
Yes, sir.
we will normally talk about in thermodynamics, first one, second one. Third one we don't speak. So the first, if I give an example, So can I give a conducting, non-conducting? Take a beaker, put water. Yes or no? Put water. So inside is a system. This outside part, the walls are what? The boundary. Yes or no? And immediately
Yes, sir.
outside is surrounding, and rest is universe. Clear?
Yes, sir.
Now we will talk about state of the system. Write down a definition. Properties which define state of any system are called state variables or thermodynamic variables. Property which define state of a system are called state variable or thermodynamic variable or thermodynamic quantities.
Sir, एक बार repeat करो.
Properties which define state of any system are called state variables or thermodynamic variables or thermodynamic quantity. Means those variables which tell what is the state of the system. Like, what will be, you tell me? What will be? Can we say what is the state? Temperature, pressure, temperature, and what? What else? Volume. Yes or no? Yes,
Yes,
or no?
sir.
I have a system. Yes, I have a hot water. So there will be a pressure. When you heat, what will happen? The pressure will increase. Yes or no? Temperature will also
Yes.
increase, and the volume will also increase. Yes or no? When there is an
Yes, sir.
increase of temperature, the volume increases or not?
Yes, sir.
Is it so?
Sir,
Is it
if
so?
the temperature increases, the volume also increases, right?
May or may not. Now, if I take a
Okay.
piston, if you take
Because
a what do you call that, pressure, where you put a pump, no, in your bicycle. So in that, when I'm reducing volume, when I'm putting pressure is increasing, volume is decreasing, but temperature is increasing. Yes or no? You are
Yes, sir.
applying
yes, sir.
pressure, slowly the volume is decreasing. Yes or no? When the volume is decreasing, the gas is getting compressed and temperature is increasing. PVT. P increases, V decreases, T increases. But when you're heating a beaker, what happens? Temperature increases, no doubt. You agree with me?
Yes, sir.
What about pressure?
Yes, sir.
What about pressure?
Pressure will also increase.
Exactly. But what about volume? Will it decrease or increase?
Volume will decrease.
Decrease. What decrease? Liquid is
Volume.
decreasing.
Liquid.
Volume of liquid is decreasing, but volume of gas is increasing. Yes or
Because
no?
it is evaporated.
Exactly. So when you talk about a system, you talk about a state of the system. It's in the liquid state. The water volume is decreasing. When the water volume is decreasing, that means water is getting converted into water vapor. So slowly, earlier you took 1 liter of water. Slowly you are left with 300 ml of water. So 700 ml of water has become what? Gas or water vapor.
Water vapor.
Understood? I am
Yes, sir.
Yes,
I'm in a class. I'll talk to you later. Understood? Is it clear? So please understand. So
Yes,
these
sir.
variables are called what? State variables, or they are called what?
Thermodynamic variable.
Variable, or these are measurable properties. Okay, write down. The state of the system is defined by their measurable properties like temperature, pressure, volume. You have other also, you will study. Entropy, okay, internal energy, so much is there. You will study. You can write down. If you want to write down, you can write down. No problem. Entropy. Let me write down, okay? Gibbs energy. Don't get confused, huh? Not Herschel Gibbs. You know who is Herschel Gibbs?
Yes, sir. South African player.
he I think there was a match happened. I don't remember exactly. I think 2000.
South Africa chased 438
Exactly. That was the highest score
and
until
scored
now.
100.
Yes. No. Australia scored 437 or 436. These people scored
Yeah,
430.
South Africans chased that total, and
And
Gibbs scored a century.
more, I think more than a century, not 100. He scored more than that. That was an amazing match. And I
Yeah,
believe
yeah.
that South Africa is a very much better player than Australia. I believe. I don't know. What
But
others
at
feel.
the moment, no.
But unluckily, South Africa never won a World Cup. At the moment, yeah, you may say, but the time when Nicky,
Earlier their team were
yeah,
something else.
yeah, when the team was Nicky Knight, Ashu Gibbs, Hanshik Ronnie,
James Smith, Dale Singh, Moni
Lance,
Monkel, ABD Villiers. The list is long.
yeah, Lance Krusina, yeah. That time the players were and Jonty Rhodes, so
John T. Rhodes.
everybody was a legend. Okay, so Gibbs energy. Next, enthalpy. Symbol is H. This symbol is G. Internal energy, E or U. Clear? Temperature, pressure, volume. These are called what? State variables, or these are measurable properties. Is it clear?
Yes, sir.
Yes.
So based on that, you have two types of function. One is state function, one is path function. What is state function or path function? When you say path function, that means what? When I say path function, what do you mean by that? You remember conservative, non-conservative force? I think Harsh will remember. We taught in the 11th class.
No, sir, I
Conservative,
was not. I left the class.
conservative force are path dependent, non-conservative or non-path dependent. Yes, those forces. So path function means, state function means these functions or these variables depend only on the initial and the final state, but does not depend on the path, does not depend on the path or the mechanism followed by the system to achieve final state. Write down the definition. These state variables like just now we saw S, G, U, T, P, V. Okay, all these are what? These state variables depend only on the initial and the final state. Depend only upon the initial and the final state of the system, but does not depend upon the path, or mechanism followed by the system to achieve that final state. Does not depend on the path or mechanism. Like we say, no, Rishabh, what do you want? I want mangoes. Okay, I'll give mangoes. Can you do this? Then Rishabh will, after I give mangoes, Rishabh will say, sir, mango किसने लाया? कहाँ से लाया? मैं बोलूँगा, Rishabh, what do you want? I gave you mangoes, no? Don't count trees. आम क्या आम गुठलियों के दाम. Don't ask me how I got. I gave you. You required. You understood, guys? Don't ask mechanism or path. Just initial and final state. You wanted mangoes, mangoes are given. Don't ask me where it came from. Is it clear to all of you?
Yes, sir.
And example are
Yes, sir.
given. All this. So then what is next? Path function. Write down. Path function are the properties of the system which depend upon the initial and final state of the system as well as the path. They depend on both initial final state and also on the path or mechanism. They are called path function. Example, work done or heat. Yes or no?
Sir, depends on.
Depends on both initial state, final state, and also the mechanism or the path you achieve the final state. This will only depend on the initial and final state, not on path. So you can remember like this: state function are path independent. Path function are path independent. Simple. Shortcut if you want to remember. State function depend on initial and final state, not on path. But path function depend on initial and final state and also on path. Example, these are entropy, pressure, temperature, volume, Gibbs energy, and this one will be work done, W or heat. Now you tell me, sir, why? Why are we talking these are path function? Very simple. If I want to do work, work will depend on how much I traveled. You agree with me? You agree with me or not?
Yes, sir.
That means what? The path, the distance covered is a function which is depending. If I covered this much path, then the work done is less. If I done more distance, then it will depend on. Similarly, heat. That means I have a longer rod, okay, and I am burning a candle. I have a shorter rod. I am burning a candle. Both sides is being held by a boy. Now tell me, who will feel heat more and who will feel heat soon? This one, yes or no?
Yes,
Why?
sir.
Because the heat
Yes,
has to travel.
Distance is less.
Traverse what? More distance
More
here.
different.
Exactly. But pressure, temperature, volume does not depend. They are path independent. They do not depend. They do not depend at this pressure because this one temperature do not have to travel anywhere. Heat has to travel. Temperature is not increasing. Did you understand? Temperature is not traveling. Heat is traveling. Is it clear? Is it clear to all of you?
Yes, sir.
Next, we'll talk about what are thermodynamic properties. Write down. There are two types of thermodynamic properties. First property are called intensive property. Are called intensive properties. And the second called extensive properties. Intensive property, extensive property. What do you mean by that? Write down definition. The property of the system which are independent of matter present. Independent of matter present are called intensive properties. Independent of matter present, size, mass. Okay. What is the size? What is the mass? They are called intensive properties. What are the extensive properties? Which are dependent on matter. Which are dependent on matter. Like example, I'll give an example. You tell me. I have a box. Okay. I have a box which has 10 kg of mass. Okay. I have a bigger box which has also 10 kg of mass. Now tell me, what varies? What is varying? Mass both is same. You agree with me? 10 kg. You agree with me? Mass is 10 kg. But what is
Yes,
varying?
sir.
What is varying?
Size.
Size, yeah. But what is varying? Volume is varying. Here the volume is V1. Here volume is V2. V2 is greater than V1. But is the mass same?
Yes, sir.
That means what? Mass is a what? Does not depend on the size. Mass is mass, whether bigger or smaller. But what is varying? Volume. Volume is it depends on the volume. It depends on the size. Bigger size, bigger volume. But mass is same. So volume is a what? extensive property. Is it clear? Is it clear? And what is density? Density, what is density? Rho. Mass by volume. You agree with me or not? You agree with me or not?
Yes, sir.
Density, rho, density does not depend on the what? Size or matter. Whether big or small, the density will be same. You agree with me or not? You agree with me or not?
Yes,
If
sir.
I take a bigger,
Yes, sir.
I take a big building, or if I cut a small brick, the small brick density will be same as the bigger building. You agree with me or not? Why? Density is just a part, it's just a constant. So write down. So what are the intensive property? What are extensive property? Intensive property, extensive property. Intensive property, first, density. Second, molar volume. You have studied in science. Specific heat. Fourth, pressure. Fifth, temperature. Six, refractive index. 7, pH value. 8, surface tension and viscosity. Some of the, I gave example of some of the only. You can have more. Boiling point, freezing point, all that. What are extensive properties? Volume, number of moles, mass, entropy, enthalpy, internal energy, force, and surface area, and heat capacity. Is it clear? Is it clear?
सर
Yes.
एस क्या है?
कौन सा? S है एंट्रोपी, H है एंथैल्पी. ये लोग हम पढ़ेंगे. All this will study later. U is internal energy. I taught in the last class. You can see, Harsh, you can see the video. Is it clear, guys?
Yes, sir.
Yes, sir.
Some special point if you want to remember. Special point. The ratio of 2. So what is density? I also told density equal to mass by volume. What is mass? Mass is an extensive property. What is volume? This is also extensive property. You agree with me? But the ratio of 2 extensive property is what? Intensive property. Is it clear?
Yes, sir.
Is it clear?
Yes, sir.
Yes, sir.
Good. So now we will study about various types of thermodynamic processes. What are the various type of thermodynamic process? Very, very important. So the first example. So basically, what is thermodynamic process? There is a system. Yes or no? System undergoes a change from one state to another state. You agree with me? You have taken a bucket of water, beaker of water. There only water, but slowly you are increasing temperature. So is the system same state? Is it so? Or it has changed the state? Yes?
So it will change.
Yes. It is no more the same state. Maybe slowly the water will boil, the system will undergo change. So initially small vapors will be there, more water will be there. After some time, more vapor, less water. Then after that, only vapor. Yes or no? So based on the timings, it will get changed. So write down, when a system undergoes a change, when a system undergoes a change from one state to another state, this operation is called thermodynamic process. This process is called thermodynamic process.
So can you repeat?
When a system undergoes a change from one state to another state, this change or this operation is called thermodynamic process.
Yes.
1 minute now. Okay. So this thermodynamic process can be either by expansion or compression. Like I take an example of the pump, cycle pump. So when you say cycle pump, there is a piston, yes or no? So when you are putting the pressure, what is happening? The compression is happening. You agree with me? Compression
Yes,
is
sir.
happening. But after some time, you're taking it back. So what is happening? Expansion is happening. So they can have two types, expansion and compression. Okay. So now we will talk about various type of thermodynamic process. The first process is called isothermal. Isothermal. When you talk about thermal, what do you mean by that? What do you mean by thermal? Yes, anybody?
Temperature.
Very good. So this system will have the constant temperature. Temperature of the system during the entire process will be constant. There will be no change. That means your delta T will be 0. Whenever the system started, initial and the final state, system undergoes a change. During this process, the system, there will be no change in temperature. That means the delta T will be 0. Whatever is happening, delta T is 0. First point. Second point, heat is exchanged. Heat is exchanged to the surrounding. Third, volume and pressure are variable. Volume and pressure is variable. Temperature is constant, but not volume pressure. Volume and pressure is vary. Is it clear? Is it clear?
Yes, sir.
Write down. First point, temperature delta T is 0 or temperature constant. Second, heat is exchanged to the surrounding. Third point, volume and pressure both are variable.
Sir, third point.
Volume and pressure are variables. They're varying. कर रहा है काम? हाँ ठीक है ठीक है, कर लिया ना तूने जतिन का? Okay, have you all written down? Next we'll go to isobaric process. Now tell me, by the word itself, what do you mean by that? Isobar. What do you mean by that? Who will tell? Who will tell? Hello.
Yes, sir.
What is mean isobar? Baric. First point.
Sir,
Pressure.
same number of nucleons.
Isobaric. Bar is the
सर
unit of
आपने आइसो बार पूछा ना.
baric लिखा मैंने, baric. Isothermal. Iso means same. Thermal means temperature. Iso means same. Baric means pressure. Okay. Then we'll go to isochoric. Choric means volume. Isobaric, the process which involves constant pressure during entire process. Or sorry, the pressure of the system remains constant during entire conversion or change is called isobaric process.
एक बार रिपीट करो ना.
Process of system remains constant during entire process. अरे पहला एग्जांपल कौन देगा? Who will give me the first example? Isothermal. We have already studied types of system. Tell me which is the process? Which one? Thermoflask. Because in thermoflask, what you are doing? Your temperature is constant. Yes or no? Is it so or not? Yes or no?
Yes.
Though
Yes, sir.
though it is not exactly constant, slowly the temperature will reduce, but if you say it is almost constant, it will at least, if you take hot water, you will see at least for 3-4 hours it will not change. Yes or no? It will remain constant. So second, pressure of contact, you wrote. Second point, the volume and temperature both are variable. What are the variables here? Both volume and pressure. Sorry, volume and temperature. Agree with me?
Yes.
Yes, sir.
Example. What is the example? Very simple example. Take a beaker, put water. That's it. Why? You know very well, whenever there is a water, on the top of the water, it is exposed to the environment. So that means atmospheric pressure. Yes, yes or no? Yes or no? We studied no in pressure
Yes, sir.
chapter. Water is here. The point here, all is same pressure. You agree with me? Why? Because it is exposed to atmosphere, 1 atm, atmospheric pressure. In gauge pressure, atmospheric pressure, we studied no? Yes or no? So an open vessel kept outside is an example of isobaric or isobaric in nature. A open system is isobaric in nature. Open system in anything, put hot water, cold water, anything you want to put, it is isobaric in nature.
सर सेकंड पॉइंट क्या था एक बार?
Volume and temperature are variable. First point, pressure is constant or there is no change in pressure. Delta P is 0. Second point, both volume and temperature are varying or variables. Third point, process in an open system is isobaric in nature. Anything. Take a tumbler of water, beaker of water, bucket of water, keep it outside. Clear? Now we'll go to the third process. Isochoric. Isochoric. Choric means volume. Simple. Volume is constant or delta V is 0. So the process which undergoes no change in the volume is called isochoric process. Delta V 0 and pressure and temperature are variables. Is it clear?
Yes.
So the work done during the process is always 0. Why? Because delta W or work done is nothing but P delta V. I will come to that in the next class. I will tell you. W equal to P delta V. When delta V is 0, then what is P into 0 is equal to 0. So work done is also 0. Fourth point. Closed system. A closed system is isochoric in nature. A closed system is isochoric in nature. Clear?
Yes.
Yes, sir. How much time is left? Okay. Next, adiabatic process.
10 minutes.
Yeah, we'll finish. Adiabatic process. What is adiabatic process? Write down. In adiabatic process, where no exchange of heat between system and surrounding takes place during entire process. That means all the variables, temperature, pressure, volume is increasing, I mean changing, are varying, but the heat is completely constant. Is completely constant. And this adiabatic process, any insulated container is an example. Why? Because in an insulated container, heat is not exchanged outside. Everything is changing, but heat is not. Heat is completely sealed inside. Is it clear?
Yes, sir.
All of you clear? Any doubts till now?
Yes.
No, sir.
And the last is cyclic process. Write down. What is cyclic process? When a system undergoes number of different processes and finally returns to the initial state. When a system undergoes different process but finally returns back to its initial state, it is called cyclic process. Is it clear?
Yes, sir.
What is the example? Just think any example. Any example? Working of a motor. Working of a motor or turbine. Is it clear?
Yes, sir.
Or,
Yes, sir.
or air conditioner or refrigerator. Why? Air conditioner. AC, what do? Initially it is off. You on it, you use it, and again you get switched off. Again it goes to the initial state. Yes or no? Or continuously it gets on forever? No, right? No, right? Or an engine. Engine starts, it again comes back to the original state. Yes or no?
Yes, sir.
Write down examples of cyclic process. Is it clear to all of you? Please study. Everybody study thermodynamics. If you don't study, you will not understand. We are still not started. Main thing, main topic is still there. Another 2-3 classes are left still. Please study. Next class, I will study more detail. Okay. Okay, all of you.
Yes, sir.
Okay, sir.
Sure.
Yes, sir.
Yeah, take care. Bye.